Hello, I welcome you all to this class. Now, before starting the numerical problems, we will see the small topic that suppose any section is given and then how to know that the given section is symmetric about which axis. Means either it is symmetric about the x-axis or symmetric about the y-axis. Why? Because the symmetricity will decide that about which axis you have to find out the centroid. So let's say that symmetricity is nothing but that if any body is symmetric about the x-axis, it means that the given body is concentrated about the x-axis, means that the given section will be in equilibrium about the x-axis. Okay, and if it is symmetrical about the y-axis, it means that it is symmetrical about the y-axis. So let's take very simple example. Here I am taking one I section, right? This is your I section I am drawing. Okay, so this is your I section. Before starting, I tell you that this portion, that is top portion, top rectangular portion, is known as the flange, or you can say this is the top flange, right? And the bottom rectangular section is known as the bottom flange. Okay, this is known as the bottom flange, and the vertical section which is in between these two, it is known as the web, right? So this is the how you can specify the I section. So now first of all, this is the I section whose centroid you have to find. So first of all, you need to know about which axis you have to find the centroid, means either x-axis or y-axis. So for that, you need to know that given section is symmetrical about the which axis. So to know the symmetricity, if I want to know that whether it is symmetrical about the x-axis or not, right? So first of all, I'll draw, means I'll cut this I section into two parts along x-axis. So this is the x-axis, is it or not? Right? So this I section I have splitted it into two parts. Now we have to see that whether these two parts, if these two parts is having equal weight after splitting, it means that the given section is symmetrical about the x-axis. Okay, now if I have cut like this about the vertical axis, and then you'll get the two part, this which I am shading, right? And if you found that these two part after splitting about the y-axis, if these two part is also having equal weight, it means this is also symmetrical about the y-axis. Then how can you know that? Means the dimension will decide. See here, the top flange and the bottom flange is having equal dimension. It means that the material which is reinforced into this section is of having equal, means uniformly in the bottom and in the top. Now one more section we can say that, let's say this is your channel, right? Or we call it as a C section, is it or not? This is the C section. If I want to know whether it is symmetrical about x or y, so first of all I have to split this channel or C section about the x-axis in two parts, so you can find that both the part is having equal weight. It means that it is symmetrical about the x-axis. Now if I split this part section about the y-axis, you can see this part is having more weight, right, than this. It means that it is not symmetrical about the y-axis, right? So one more example you can take here itself. Let's say this is your T section. This is your T section. So this is the top flange and this is the web, right? If I cut like this about x-axis, you can see the bottom is having something dimensions and the top is having something else. It means that these two part is not having equal weight when we are splitting this about the x-axis, but while we cut it about the y-axis, we'll get the two equal weight, right? So it means that the given section is symmetrical about the y-axis, but it is not symmetrical about the x-axis. Okay, so this is how we need to know that the given section is symmetrical about the which axis. Now we'll move to the further and we'll start one problems. So that first we'll begin with the composite body, means the centroid we have to find for a composite section. Composite section means what? The section which is made up of the more than one sections, right? Means one figure, more than one figure is included, that we can call it as a composite. Composite means more than one, right? So here if you look at this, the question is on the screen that using analytical method determine the center of gravity of the plane uniform lamina. So the figure is given here. So if you see the different geometrical object is there, right? That is, if you observe very carefully, you can find that one rectangle is there, semicircle is there, and the triangle is there. The dimensions is mentioned here, that this is your, so whenever any plane is given, that we need to see that on, means that we try to keep that object on the xy plane. So let's say this is my reference, that is vertical over y axis, and here itself it is the x axis, right? So this is the x, let's say it is O origin, and this is the y, right? So now, so first of all we need to know whether this the figure is symmetrical about the which axis. So for that, just now we have discussed, let's try to know about the x axis. If I'm splitting this into two equal part, you can find that from here to here you have a one rectangle. It's look like half of the rectangle and half of the semicircle, means it's like a quarter circle. But on the another part, that this is also half of the rectangle and one quarter circle, but additionally these two part, there is a one triangle is there. It means that the upper part is having more weight than the lower one. So on behalf of that, you can say the given section is not symmetrical about the x axis. Now let's come back to the y axis. So for y axis, we are splitting this into two part, like vertical axis will draw, and then you can see that the some portion of the rectangle and semicircle. In this you have a rectangle and triangle. Obviously both the part is geometrically they are not similar, so it means that the weight will also not equal, right? So it means that the given object or the given section is neither symmetrical about the x axis nor about the y axis. So it means this section is an unsymmetrical section. So when the object is not symmetric neither x axis nor about the y axis, it means that is unsymmetrical, and for unsymmetrical section we have to find out the center of gravity about both axes. So now let's start the solution, right? So you can say here the given lamina is unsymmetrical, unsymmetrical means what? Unsymmetrical, right? So it means that we have to find out the x as well as the y. So before finding that, analytical method is what? That for x bar, a1 x1 plus a2 x2 plus so on, so by a1 plus a2. So now you can figure out how many object is there. So in this rectangle, semicircle and triangle means 3. So let's say I am considering this rectangle, this whole rectangle as a 1, right? And the semicircle as a 2 and the triangle as 3. You can consider this semicircle also 1, this is 2, this is 3, this is 1, this is 2, this, it's your wish. So I'll consider the rectangle as a 1, semicircle as a 2 and the triangle as a 3. So first of all, we need to find out the area of these three bodies, right? So let's do that. So we can say first the A1 is equal to what? A1 is equal to, see this, for rectangle we can see 10 the length and the width is 5. So 10 into 5. For semicircle, radius is 2.5. These all dimension in centimeter. So for this triangle, the base is 2.5 plus 2.5 and the height is 5. So now simply you can say A1 is equal to 10 into 5, which is 50 centimeter square, right? And A2 is equal to pi r square by 2. right? Pi r square by 2. Then you can say this pi is pi by 2 into r is what? 2.5 square. So a2 is what? That a2 is nothing but, you can do the calculation, a2 is equal to 9.82 centimeter square. Then a3 is what? Half into base into height, that is triangle area. So it is what? Half, base is 5 and height is also 5, so 2.5. It means it is the 12.5 centimeter square. All right. Okay. Now then, after finding this, we need to find out the x1, x2, x3, y1, y2, y3. So just wait. So here itself, see, this figure will take for the reference right now. So x1. Now if I look at that, this is your reference, that is for x-axis, the OY is the reference. So rectangle is located at what distance? If you observe, the rectangle is located at a distance of 2.5 from the x-axis. So it means that for this, when you have to find out the centroid of the rectangle, you need to add this distance, right? So x1 is equal to what? That x1 is equal to 2.5 plus the rectangle x coordinate is what? Half of the length, that is 10 by 2. Okay, it means it is the 7.5 centimeter. All right, 2.5, why we have added? Why? Because the rectangle is not exactly on the OY axis, but it is at a distance of 2.5 centimeter. So that's why we should add, and then we'll impose the whatever the formulas or whatever the relation for the centroid, right? x2, it is what is called semicircle. So as the semicircle is kept horizontal, right? So it's x coordinate is what? X coordinate is 4r by 3 pi, but 4r by 3 pi means what? 4r by 3 pi from the base. So base of the semicircle is this one, right? So it means that we need to subtract the radius from the semicircle. So x2 is what? R minus 4r by 3 pi. All right. So r is what? 2.5 centimeter minus 4r by 4 into again 2.5 by 3 pi. Why? Because the semicircle centroid is at a distance of 4r by 3 pi from the base. So base of the semicircle is here. So that's why we are subtracting. But you're finding the centroid from OY axis. So that's why you have to subtract the r. Right now. Now next is what? Next is the x3. So if you look at this, triangle is located at what distance? 2.5 plus 5 centimeter, and then this is base for this triangle, that its median will be lying at this point right now. So it means exactly at the b by 2, means what? That you can say 2.5 plus 5 plus 5 by 2, means it is 7.5 plus 2, 10 centimeter. Okay, now we will impose these values into the empirical relation. So x bar is what? That x bar is equal to a1 x1, so you can shift now little bit, plus a2 x2 plus a3 x3 by a1 plus a2 plus a3. So what is that? Substitute all the values. So you can get the reference here. Just wait. Sorry. So a1 is 50. Just hold on for a second. So a1 is 50. X1 is what? 7.5 plus. Here we can take. A2 is 9.82, and x2 is your this. This value will be, x2 is 1.43 from that y-axis. So 9.82 into 1.43 plus a3 x3, a3 is 12.5 into x3 is 10, right, upon a1 is 50 plus A2 is 9.82 plus 12.5. So x bar we got, sorry. So x bar is, after calculation you may get the x as a, okay, I'll let you know, x bar is equal to some. Then now we have to find out the y coordinate. So y bar is what? A1 y1 plus A2 y2 plus A3 y3 by A1 plus A2 plus A3. Okay, now, so first of all, A1, A2, A3 will be same for both the figure, for both the cases. But y1 is equal to what? Y1 is equal to, for this rectangle it is half of the depth, for this semicircle is kept vertically, so y coordinate, centroid about the y axis for the semicircle is radius, which is 2.5, and for this it is h by 3. But at what distance? The triangle is located at a distance of 5 meter 5 centimeter from the OX axis. Why? Because for vertical you have to choose the reference as a OX, right? So now y1 is equal to 5 by 2, which is 2.5 y1. Y2 is equal to radius, which is 2.5 centimeter itself, right? And y3, this is y3 is equal to 5 plus 5 by 3, right? That is h by 3 it is. So 5 plus 5 by 3 means 6.67 centimeter. This is also centimeter, right? Now we can impose the formulas. So formula is what? That y bar is equal to A1 y1 plus A2 y2 plus A3 y3 by A1 plus A2 plus A3. So A1 is what? A1 is same, that 50, and y1 is 2.5 plus A2 is what? A2 is 9.82 into y2 is 2.5 plus, sorry, I'm very sorry, that A3 is 12.5 into y3 is 6.67 by 50, sorry, 50 plus 9.82 plus 12.5. So after simplification, y bar is equal to that is 7.11, okay, and x bar is equal to 3.33 something will come, 3.31 centimeter, right? So now your answer will be like this, that is, just a bit, that you can write like this, that x bar comma y bar is equal to what? Is equal to 3 point, how much we got? 31, right? 3.31 comma 7.11. This is your answer. So this is the way how to find out the center of gravity of the composite body. Now one more problem we will discuss, that this problem is about the cutout section. So the problem is on the screen. You can see that from a circular plane of diameter 100 mm, a circular part of diameter 50 mm is cut. Find the centroid of the remainder. So it means that such figure is known as the cutout section. So actually the center of gravity is what? The center of gravity is a point where the whole weight of the body can be packed. So it means that if you look at this, let's say that this is one plate is there, right? So this plate is having weight. So when we find the center of gravity, that plate is circular, so its center of gravity will lie at the center. But imagine that we have removed this much of material from the plate. So it means that now the weight is not as a previous one. So it means that the weight has reduced. So it means that when the weight has changed, it means that the center of gravity of that particular body will also change. So in that case, whenever there is a material is removed, so that portion or that section we call it as a cutout section. So for cutout section, the analytical method, we are adding the area moment like a1 x1 plus a2 x2 plus so on so. But in cutout section means whenever the material has removed, it means that we won't add, but that particular section or that particular part we should subtract, right? So two circular plate is given. One is at this of having diameter is 100 mm, and the one is cutout section. This is hole is there whose diameter is 50. So while we find out this composite section, the center of gravity of the composite section, that we need to remove this section. Why? Because there is no weight, right? So first of all, we need to know that whether the given section is symmetrical about which axis, right? So let's say if I cut like this, is it or not? It means that you can find the top and bottom is having equal dimension. It means that the equal weight is there. So the given section is symmetrical about the x-axis. But if you want to know that whether it is symmetrical about y-axis also, so let's say that cut about this. So you can find this side is having more material and this side we have a cutout section. It means that this half portion and this half portion is not having equal weight. It means that it is not symmetrical about the y-axis, but it's symmetrical about the x-axis. So in this case we will find the center of gravity only about the x-axis. So you can say first that the given section, is symmetric about what? About x-axis. So now then you have to decide that which one is 1 and which one is 2. Let's say that the bigger diameter, the bigger circle whose diameter is 100 mm is 1, and the 50 mm diameter of circle is 2. Now so x bar is equal to what? So you can say that x bar is equal to a1 x1 minus a2 x2 by a1 minus a2. Simply, so a1 is equal to what? That a1 is equal to pi by 4 d square, that means pi by 4 into 100 square, the diameter, right? So that a1 is equal to, you can get the value as 7853.98. The dimension is millimeter, so the mm square. Now a2 is equal to what? That's a2 is also pi by 4 d square, but the d is 50, which is 50 square. Directly I am writing, so it is 1963.5 millimeter square. Now x1, so the for circle the centroid is at their center, right? So and for this the reference is this one, y axis, for x axis, right? So its center is exactly that. For the 100 mm diameter, the centroid will be at their center, which is the radius, right? So you can say that x1 is equal to radius, which is nothing but the 50 mm, right? But what about the x2? See, I'll tell you very carefully, you need to see. For this x2, for this 2, actually the center of gravity or centroid of that section, that of this smaller circle, will be at their center, right? But our reference is what? Our reference is y dash, right? So it means that where it is, from here this will be, it means that either you have to add this radius plus this, right? Or another way you can say that the total diameter minus radius. Are you getting my point? Right. So now you can say, so x2 is equal to what? It is located at what distance? It is located at a distance of 50 mm from the y axis. Again you can see that this circle is located at a distance, this circle is located at a distance of 50 mm of this radius from the y. Why? Because for x axis our reference is y1, right? So x2 is what? 50 plus that circle has centroid is the center, that center is nothing but the radius, which is 25, is equal to 75 millimeter, right? Put these values into that equation, you will get the answer. So here, yes, so again you can say x bar is equal to what? a1 x1 minus a2 x2 upon a1 minus a2. So a1 is what? a1 is your 7853.98 into x1 is the 50, right, minus a2 is what is that? a2 you can see 1963.5, right? So a2 is 1963.5 into 75 by 7853.98 minus 1963.5, right? So the x bar is equal to 41.67 millimeter, right? So it means that your answer will be like this: x bar comma y bar is equal to 41.67 comma 0. Why? Because it is not symmetrical about the y-axis. That's why we have taken y coordinate as a 0, right? Now you can locate this center of gravity. That center of gravity you can locate. So your reference is what? Your reference is the y-axis, right? So it is at what distance? This total is 50. We got the x value is 41. 41 means it will be somewhere here, right? So this you can mention x bar is equal to 41.67. all right. So this is how we need to find out the centroid of a given section. In the upcoming classes we try to solve some more problem. Thank you.